This video will be part 3 of solving this 1969 AP Calc AB multiple choice portion. Okay, so there's actually quite a few problems in the last 2 pages, but we're going to do it all in this video. Okay, so let's begin. Which of the following is an equation of a curve that intersects at right angles? Every curve of the family y is 1 over x plus k, where k takes all real values. Okay. This is saying intersects at right angles, so tangent line doesn't touch the curve, right? Oh, it touches only at one point, sorry. It doesn't intersect the curve, I'm trying to say. When it intersects at right angles, that's perpendicular to the tangent line. Okay, so let's find the general equation for the slope of the tangent line, which is just y prime. Y prime, which is minus 1 over x squared. Okay, so we want it to intersect at right angles, so we want to invert this. So it would be y prime is equal to x squared. Let's invert. Okay? Negative reciprocal. Sorry, that's the precise term. Negative reciprocal. Okay? So if y prime is equal to x squared, then y is equal to a third x cubed plus some constant c. Okay, so the answer is D. That's one curve, because let's just c is 0. Okay, that's how we do that one. At t is 0, a particle starts at rest and moves along a line in a way such that at time t, its acceleration is 24 t squared feet per second. Through how many feet does the particle move during the first 2 seconds? Okay, excuse me. This is probably solving this differential equation. Let me get a piece of scratch paper. We're given that acceleration is 24 t squared. At t is 0, particle starts at rest. So v of 0 is 0. Okay? Velocity is just the integral of acceleration, or the antiderivative. So what would that be? That's 24 over 3 t cubed plus c, which is 8t cubed plus c. They give us v of 0 is 0, okay? So we just plug in 0 as t. So it'll be 8 times 0 cubed plus c. So c is equal to 0. So our particular solution for velocity, this was the general solution. Particular solution, a general solution here. Particular solution is 8t cubed, okay? Position would be the integral of velocity, which would be 8 over 4 t to the 4th plus c, which is 2 t to the 4th plus c. Okay. Actually, did we even need to do this? It says, through how many feet does the particle move during the first 2 seconds? So we want to integrate, to do the definite integral from 0 to 2 of v of t dt. Okay, so actually, by the way, v of t is positive, so it's moving in one direction. This is always positive. One is from 0 to 2, so we don't have to worry about the sign. Okay, so we can just do 2t to the 4th, evaluate from 0 to 2, which is 2 to the 4th is 16. 16 times 2 is 32. So is that the answer? 35 is A. Yes. Okay, so that's how we do this. They give us the acceleration, we find the velocity, and they give us the initial condition for velocity, so we can get particular solution for velocity, at cubed. Position, or it's asking about how many feet does the particle move, so we do the definite integral of the velocity. Okay, which is 32. Excuse me. Approximate value of y is square root of 4 plus sine x. At x is 0.12. Obtained from the tangent to the graph at x is 0 is what? Okay, so this is linear approximation. So let's just find the equation of the tangent line. So if y is square root of 4 plus sine x, y prime would be 1 over 2 root 4 plus sine x times derivative of the inside, which is cosine x. Evaluate this at x is equal to 0, which is equal to, well, we get 1 over 2 root 4 times 1, which is 1/4. 1/4. This is the slope of the tangent line. Okay? When x is 0, then y is what? That would be square root of 4. It's 2. So our point is 0, 2. Okay? We have a point. We have a slope. Equation of tangent line is this. Okay, so y is 1/4 x plus 2. Now we're going to use this tangent line to approximate y at x is 0.12. So y would be 1/4 times 0.12 plus 2. Okay, so this is 2 plus 0.12 divided by 4 is 0.03, so 2.03. Okay, that's how we do that. Which is the best of the following polynomial approximation to cosine 2x near x is equal to 0. Okay, so if you know BC calculus, this should be very easy, but this is AB. I don't think they taught, even back then, the Taylor series. Okay, so how would we do this? Well, first of all, AP Calc AB, you either differentiate or integrate for maybe 90% of the problems. So probably want to pick one of those. Okay. Polynomial approximation to cosine x near x is equal to 0. Probably let's try to differentiate these guys. We want the derivatives to be close to each other. Okay. So if y is cosine of 2x, y prime would be negative 2 sine of 2x. When we evaluate this at x is 0, we would get 0. Okay, so which one would give us, which one of these would give us a derivative at 0 of 0 also? Okay, if we differentiate this, that would be half. That's constant, which is not 0. To differentiate this, this would be 1, not 0. This would be what? This would be negative 2x divided by 2, which is negative x. When x is 0, then it's 0, so that's possible. How about here? Negative 4x. When x is 0, then it's 0, that's possible. Over here, that's also possible because it'll be, actually, it will not be possible because it'll be negative 2 plus 2x, so it'll be negative 2. So we eliminate A, B, and E. Okay? We're left with C and D. So let's start taking another derivative. Y double prime. That would be what? It would be minus 4 cosine of 2x. Evaluate this at x is equal to 0. That's equal to what? Or, sorry. Minus 4. Cosine of 2x would be 1 when x is 0. Okay, so minus 4. So what second derivative is minus 1? So, sorry, minus 4. I keep saying the wrong thing. It would be, looks like it'll be this one because it'll be, the first derivative is negative 4x, second derivative is negative 4. This one, first derivative is negative x, second derivative is negative 1. Okay, so it'll be D. Okay. If you know the, actually, yeah, that should be this, okay? Yeah, if you know the Taylor series, then you'll also see that it's this one, okay? Because this would be for cosine x, but cosine 2x would be this one, okay? This one, we just do a substitution. I can see it right away. We let u be x cubed, so du would be 3x squared dx. So we integrate this from, if we do the substitution, this is not a definite integral actually, so it'll be e to the u on the bottom. X squared dx is du over 3, x squared dx, so it'll be du and a third. So this is just minus a third, e to the negative u, because du over e to u is same thing as e to negative u du, okay? So plus c is minus a third, e to the minus x cubed plus c. So which one is that? this one looks like. Okay? Excuse me. Okay, if y is tangent u, u is v minus 1 over v, v is ln x. What's the value of dy dx that x is equal to e? Okay, so this is, we probably need the chain rule. So dy dx, y is in terms of u, so dy du, u is in terms of v, du dv, v is in terms of x, dv dx. Okay, so if you kind of cross these out, you get dy dx again. Okay, so what's dy du? That is just secant squared, right? Secant squared of u okay, times v minus 1 over v would be 1 plus 1 over v squared, and then derivative of dv dx, so that would be 1 over x, okay? Okay, so let's start plugging in. Well, we need u when x is e. So when x is e, ln e is 1. So 1, that's v. V is 1. 1 minus 1 over 1, that would be 0. So it'll be secant squared of 0. Okay, so when e, we said v is 1. So it'll be 1 plus 1 over 1 squared. And then this is 1 over e. Secant of 0 is 1. Secant squared of 0 is also 1. This is 1. This is 2. This is 1 over e, so it's 2 over e. 39 is d? Yes. Okay, so this is the chain rule. Okay. We have quite a few problems still on this page. If n is, let me shift it a little bit. N is non-negative integer, integral from 0 to 1, x to n dx equals 0 to 1, integral from 0 to 1, 1 minus x to n dx for what? Okay. I'm thinking we can maybe just make a substitution for one of the sides. So let me rewrite it. Integral from 0 to 1, x to n x is... Okay. So if we let u be 1 minus x, du would be minus dx. Okay. So I'm substituting this side. So we change it to the integral of, well, when x is 0, u is 1. When x is 1, u is 0. So it'll be u to the n times minus du. Okay, which we can invert it to 0 to 1, u to the n du. Okay, this is the left-hand side still. Okay. So these look exactly the same, actually. So, which choice is it? Okay, it's probably for all n, since once we made a substitution, it's the exact same. Just the variable is a different name. We could change the u back to x even. It'll be the same thing. So it's for all n. Okay. We have this piecewise function. Then integral from -1 to 3, f of x dx is a number between what? Okay, so how did we approach this? From -1 to 3, so it goes on both sides actually, okay? So, how do we do this? Well, okay, maybe let's write it out. Don't have space, okay, so from -1 to 3, so -1 to 2 would be this portion. Okay. And then from 2 to 3, it would be x squared. Okay? So we could just solve it even. It's not that hard. Okay. It'll be what? It'll be 8x minus x cubed over 3, evaluate from minus 1 to 2, plus x cubed over 3, evaluate from 2 to 3. So this is equal to what? 16 minus 8 thirds minus 8 minus negative 8, sorry, minus negative 8, and then negative 1 cubed is negative 1. So there's another negative, so positive 1/3. Okay, that's this one. And then plus, it'll be 3 cubed is 27 over 3 minus 8 thirds. Okay, so this would be 16 minus 8 thirds plus 8 minus a third plus 9 minus 8 thirds. So 16 plus 8 plus 9, 16 plus 17, that is 33. Okay, minus 16 over 3 minus another third, which is 33 minus 17 over 3. Okay, so what's 33 minus 17 over 3? Well, this is, what's 17 over 3? It's less than 8, right? So it'll be 33 minus, let's say 8 even. So it should be this one. Okay, that's how we do that. So I just literally solved the integrals. Okay, we broke it up from minus 1 to 2, which is this portion of the curve, and then 2 to 3, which is this portion of the curve. Okay, so that's how we did that one. Where are all values of k for which the graph, this guy, will have 3 distinct x-intercepts. Okay, how do we go about this? Okay, if it has 3 distinct x-intercepts, say 1, 2, 3. That means that maybe it's something like this. They'll have to be, the derivative has to change sign multiple times. Okay? In fact, it has to change at least 2 times. Changes once here, actually 3 times because it's 3 roots, right? I have to change 3 times. So it changes once here, changes again here, changes again there. So we probably want to take derivative. Okay. Let me try to squeeze it in here. So y is equal to x cubed minus 3x squared plus k. Okay. So if we find y prime, that's 3x squared minus 6x. Let's set this equal to 0. Okay. Then we get what? 3x. X minus 2 is equal to 0. Is this the right method to do this? Okay, so if we have, so the critical points are 0 and 2. Let me just continue. So if we do the first derivative test, the y prime is, if we plug in a huge negative number, negative and negative make a positive, plug in like 1, those will be positive, and negative, that'll be negative total, and we plug in a huge positive number, positive, 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 okay? So we know that at 0, there is a relative max, and at 2, there is a relative min. Okay, how does that help us with this though? Well, okay, so let me do it on, let me find where my smaller notepad is. Okay, I just found this piece of paper. Okay, so we said there's a rel max at x is 0. When x is 0, so it'll be 0 comma k, and there's a relative min at 2 comma what, 8 minus 3 times 4, which is 12. So 8 minus 4 is negative 4, so k minus 4. Okay, so we want to, this is a more conceptual-like problem. So as I was saying, it has to change sign 3 times. So we want to put the max and min on opposite sides, basically, okay? So we want k to be, for example, greater than 0, and k minus 4 has to be less than 0. Okay, so k has to be greater than 0, or k has to be less than 4. Okay, so that's this one. Okay, so that's exactly what we got. Okay, so one more time. 3 distinct x-intercepts. So I just sketched how a possible thing could look. The derivative has to change sign at least here and here. Okay? So I think I said 3 times. It's actually 2 times, sorry. I keep correcting myself. The derivative had to change sign twice. Here and here. Okay? So there's 3 roots, but the derivative has to change twice. Okay? So we found a derivative. Okay? And we did the first derivative test. And we found that at 0, there'll be a max. At 2, there'll be a min. And the values of the value of the max would be k. Value of the min would be k minus 1. You just plug it into y. Okay? So the distinct roots can happen if the max and min are on opposite sides of the x-axis. Okay? If they're on the same side, it won't cross the x-axis, right? So they have to be on opposite sides. So I just said k, for example, k is greater than 0 for the max, and min k minus 4 is less than 0. So then we get that k is greater than 0 and k is less than 4. Okay? So that's how we solve that one. Okay? This one is a simple substitution. If we let u be 2x plus 3, du would be 2 dx. So it becomes the integral of sine u du with a half in front. Okay, so this is minus half cosine u plus c, which is negative half cosine, what's u? 2x plus 3 plus c. So 43 is d. Fundamental period of the function defined by this guy is what? The period it has to do with this. Well, if it's just cosine of pi x over 3, no squared, then the period is 2 pi over pi over 3, which is equal to 6. This is squared though, so the period halves, so I believe 44 is c, yeah. Because, okay, well, if you just think about this cosine, it goes like this, right? When you square it, it'll be up here instead. So essentially the period halves. So we just have the 6, which is 3. So if it was just cosine of pi x over 3, that the period is 6 by this formula. So we just have it, that's 3. Okay? If d by dx of f of x is g of x, d by dx of g of x is f of x squared, second derivative of f of x cubed is what? Okay. Here we need to be careful with chain rule. Okay? So I think we have to be careful about chain rule. So we want to find the second derivative of this guy. So let's first find the first derivative. Okay, so d by dx of f of x cubed, here we need to chain rule. It'll be f prime of x cubed times 3x squared. Okay? So then can we simplify anything here? How do we use this one? If d by dx is g of x is f of x squared, or should we just find the second derivative now? Which we need product rule. Okay, this is equal to first d second plus second d first. Let's just do it. It'll be first d second would be 6x plus second d first would be f double prime x cubed times another 3x squared. Okay, so let's clean this up. It'll be 6x times f prime of x cubed plus 9x to the fourth f double prime of x cubed. Okay, so it looks something like this. Would that be the answer? So let's try to see if we can make it look more like that. Okay, we know that derivative of g is f of x squared. So okay, so how do we relate these two is what I'm thinking now. So this part should be good. Now, we're given that d by dx of f of x is g of x, and we're given d by dx of g of x is equal to f of x squared. So if we differentiate this guy, so second derivative of f of x would be g prime of x, which is f of x squared. Does that help us? So the second derivative of f is g prime x. So we can rewrite this second term as actually that wouldn't make it look like this, because that's in terms of f. So can we make this f double prime of x cubed look like f of x to the 6th? So if we okay, this is the tough part. The easy part I already did. How do I make it match one of the answers now? Okay, so okay, if this one f prime of x cubed f prime of x cubed is just g of x cubed, because if I just use this definition, f prime of x cubed is g of x cubed. Does that match one of these? Yes. Okay, so maybe we're on the right track. This is the hard part for me. G of x cubed. Okay, now how about this 9x to the 4th? Can I make this look like f of x to the 6th? Well, f double prime of x cubed. Well, this is double prime here, which is g prime of x, which is f of x. So the second derivative of f is this. So it would be f of x squared cubed, which is x to the 6th. There we go. So that's this answer, okay? So once again, let's recap because it took me forever. We were asked to differentiate this guy, or second derivative of this guy. So we first did the first derivative, that's here. We need to chain rule, it'll be f prime of x cubed times 3x squared. Second derivative, we differentiate this guy. We will need product rule, it'll be first d second plus second d first. So first d second derivative of 3x squared is just 6x. Second d first, again we need chain rule, it'll be f double prime x cubed times 3x squared. So this is 6x f prime x cubed. Here we can combine these two to 9x to the fourth f double prime x cubed. Now it doesn't match one of the answers, so then we just made it match. Okay, it looks like this one, so I just banked on making it look like this. That was my strategy. So, and that worked because f prime of x cubed, well, f prime is this one, so that's just g of x cubed, okay? And f double prime x cubed, how did I do that? Well, I just differentiated this one once again, so that's f double prime. That's g prime, and they give us what g prime is, which is f of x squared. So it's f double prime x cubed, so instead of x, we just replace it with x cubed. So it'll be x cubed squared, or x squared cubed, same thing, which is x to the 6, okay? So that's the answer here, okay? So that's all the problems in this 1969 multiple choice exam for the AP Calc AB. Hopefully it was helpful. Please hit that like button if it was, and please subscribe to the channel to look out for more videos like this of subsequent years that they released. And if you're in BC, I don't know if you're watching this, but I'll be doing the BC ones also.